Hello, this is Dr. Lori. Welcome to this discussion on degrees of freedom. In short, the definition of degrees of freedom is the number of observations that are free to vary. And so I like to use an example of putting on my shoes. Everyone can relate to putting on their shoes. When I have not put on any shoes, then I am free to choose if I want to put my left shoe on first or my right shoe on first. And so I pick one and I put that shoe on. Once I've put my first shoe on, then I am no longer free to choose which one I do last. The last one I am not free to choose. And so in that case, I have 1 degree of freedom, and then my final shoe that I put on, I'm not free to choose anymore. Um, Similarly, when I take my dog for a walk, she gets all excited when I put my shoes on, of course. Occasionally, she has to wear some little shoes, some little booties. If we go for a hike and we're in lava country and we're hiking around a lake, her feet would get all torn up if we didn't put these little booties on her. And so I can put her first shoe on and she wiggles all around and thinks they feel funny. And then I just kind of randomly choose whichever leg is the easiest to get to for the second shoe. Um, and then I can put the third shoe on. But once I've put 3 shoes on, I'm no longer free to choose for the very last one. The last one is selected. So right at the end, we lose our freedom to choose, that freedom to vary. When the way that applies to statistics is that, like, if we're calculating the mean, and we have, let's say we have 5 observations, we're going to divide by 5. We have a certain number plus another one plus another one plus another one plus a final one. Um, and so we have these 5 numbers. We're going to add them all up together and divide by 5 and come up with the mean. Well, if we know that our total is 100 and then divide by 5, so we know that our mean is equal to 20, I can choose any number for this particular value. Similarly here and here and here. But once I get to this very last one, I cannot choose anymore because I know that they have to add up to be 100. I could choose 40 something and then 14 and 2 and 36, but then this last one has to be a specific number in order to add up to be that same 100. So the only reason that degrees of freedom is important is because in the olden days, and it's good to think about now too, but in the olden days we had to use degrees of freedom to select the p-value from a chart. Once we had calculated that critical ratio and we needed to convert that critical ratio into some kind of a p-value, we needed to know the degrees of freedom in order to do that correctly. Because of that, it is part of the APA formatting typically for the way we report statistics in a standard way. And so degrees of freedom, though, even though we don't use those same kind of charts anymore, can help us to really understand what tests were performed. So let's just say we're performing a one sample t-test. We'll use this as a good example because when we're doing a one sample t-test, we calculate just one mean. Not all tests calculate one mean, but the equation for degrees of freedom, so df, is equal to sample size, come on, size minus 1 for each mean that we calculate. So every time we calculate a mean, we lose one. We lose a spot. So my degrees of freedom, there we go, that's better, is equal to whatever my sample size is, and we would abbreviate this df equals n minus 1, n being sample size. So let's imagine that we have a sample size of 426. 426 minus 1, the degrees of freedom would be 425. Let's imagine that we had a sample of size 369. We would end up with 368 here for the degrees of freedom. We can go the opposite direction. If we knew 368, we could figure out that our sample size was 369. And because degrees of freedom ends up being part of the standard thing that we report, then a lot of times that can be helpful for us to gauge and get a sense of how large the sample was for that specific data analysis. So that concludes this discussion on degrees of freedom.